Okay, so this is this pricing decision model is not really an optimization model. It's just a very basic setup of a pricing model, which is going to be used in kind of other examples. So the idea is we sell our product for a price. There is a demand based on that price. So here, the sales, let me write that underneath. Sales equals to the beta 0, which would be 3240.9, plus beta 1, and beta 1 is negative, so it's minus 2.9485 times the price. And then, of course, revenue is going to be price times the sales, so it's going to be price times 3240.9 minus 2.9485 times price. So it actually has kind of a quadratic term there. It's not going to be a linear function. And so the idea is this is like, as your price goes up, your sales goes down. Kind of obvious. And it's a linear demand function, but the overall revenue is not linear. So we have a price here, and we're going to have kind of some sales. So let's just calculate the sales. So the price, the sales is going to be beta 0, and it's going to be plus, but it's going to be plus of negative times by the price. And that gives me my sales, which shouldn't actually have a dollar. So let's just do a format cells, just have it as a general number. And then the revenue is going to be the sales times by the price. Whoops. So it's going to be the sales times by the price. That's getting ahead of myself a little bit. And we get a total revenue of 800, just check with the book version, 883,325. Now, as a kind of an optional thing, I'm going to expand this a little bit. So imagine that we had prices kind of starting off, and we're going to have increments of 50 up to 1,000. So that would be 50 equals plus 50. And I think we go down to 21. Perfect. So then we have the price there, and then the sales is going to be, and I can just kind of copy and paste this. But instead of B5, we have D2. And we can actually have dollars, as we're going to drop. We don't want to drop these down. So we are going to drop these down. We don't change. And you can see how the sales changes with price. But we can also have the revenue. And if I do the revenue is the sales times the price. So the revenue is price times sales. And let's just draw two little graphs. Let's draw like a price times the sales graph. So let's just do insert. And we're going to have the sales. Oh, I didn't want to do that. Okay, I'm going to call this price versus sales. And let's just put the X details in, select data, right click, select data, horizontal axis, edit, and let's put the prices in here. Okay. And then we just need to add horizontal price, and the vertical is going to be sales. Now let's do the revenue. And I said this was a quadratic function, so let's just select the revenue, and let's do insert. And then that's absolutely beautiful. As I said, it's a quadratic function. So this is going to be the price versus revenue. And you see there's a trade-off here. And we could do a bit of calculus, and we could kind of minimize this function and set to 0. Something to do for fun to do on your own. And this time you see there's a trade-off. We sell less and less and less, but we get more and more in terms of price. And then that trade-off, we kind of reaches the peak here, reaches its kind of inflection point here, and then we kind of start going down the other way. So let's just do the same as before. Select data, horizontal, select the price, and you know what this is, but I like to be pedantic, and we're going to put axis titles, horizontal. It's going to be price. And then we're going to have the revenue. Where are we? In dollars. And I guess we probably want to format that in dollars. Here we go. And since we put the dollars in now, we probably don't need it in the axis title. Okay, so that was just I just wanted to show you that relationship between kind of standard pricing function, sales goes down, demand function, sales goes down with price, but we kind of put it in here, and this, so we've got revenue is 240 times price minus 2.9435 times price squared, and that you could just take derivatives and set to 0, and then you would find the optimal price around 550, which would give you the maximum revenue. So that's just, we're almost thinking about optimization, but we've not actually done any optimization yet beyond thinking that this is a little bit of calculus that we could do. And that sets us up nicely for our kind of future work on pricing. Okay.